Okay, 2.4 is called Solving Multi-Step Inequalities. And here are some things you can do that you'll want to do in order to solve them. So we want to get the variables by themselves. So I want to get the n's by themselves in both of these examples. Okay. So you can use PEMDAS in reverse. That's the inverse order of operations to isolate the variable. And I'll talk about that when I get into these examples. But also you want to, don't forget that you need to reverse the inequality symbol if you multiply both sides of the inequality by a negative number. If you're multiplying or dividing by a positive number, you don't need to worry about that. But if it's a negative number that you're multiplying or dividing by, then you need to flip the inequality symbol. Okay? So looking at this first example, I'm trying to get the n by itself. So I've got the -1 and the 3 down there to eliminate, to get them out of there so that the n is remains on its own on the left side. So, I'm going to want to add 1 to both sides to get rid of the -1, and I'm going to want to multiply both sides by 3 since it's divided by 3 to get rid of the 3. So the big question is, which one of these should I do first? And it can be a little tricky. It's tempting if you're thinking about PEMDAS in reverse, since I've got addition and division. It's tempting to think, oh, addition, if I'm doing this in reverse, I would do the addition first. But actually, when you have a fraction like this, you can think about that as a group, okay? And so I want to do, I want to actually isolate that group first. So first thing I'm going to do here is multiply both sides by 3. Okay, I'm not multiplying or dividing by a negative number here, so that just leaves me with -1 plus n is greater than -6. Okay, so now I want to add 1 to both sides to isolate the variable, and n is going to be greater than -5. -6 plus 1 is -5. Okay, so there's my solution, and now let's graph it. So this is going to be an open dot since this isn't underlined, and n is going to be a number greater than -5. Well, numbers greater than -5 are that direction on the number line. Okay. So here I've got, I'm going to need to subtract to get rid of the 3. I'm going to need to multiply to get rid of the -10. This time I'm going to do the subtraction first. Okay, so I'm going to isolate the term that has the n in it first by subtracting 3 from both sides. So here I've got 1 is greater or equal to n over -10, okay, because those cancel, right? And then I'm going to need to multiply both sides by -10. And hey, since I'm multiplying by a negative number, that means I've got to flip this around. Okay, so the arrow is pointing to the right. Let's flip that around. Now it's pointing to the left. Okay, these -10s will cancel. So now I have -10 is less than or equal to n. Okay, and that's a perfectly fine solution written like that. I like to flip it around so that the variable is on the left-hand side, just because I think it makes it easier to graph. Okay, so I'm writing those two numbers. I flipped it around, and you also want to flip the symbol when you flip the whole inequality. Okay, so if you think about the alligator is eating the n here, still want the alligator eating the n when I flip it around, like so. Okay. So then I've got a closed dot above -10. That means -10 is part of the solution, and n is any number equal to -10 or greater than it. And then when you have the variable on the left, you see how that arrow points to the right, and so does this one. Same thing over here. That's always going to work if you put the variable on the left-hand side of your inequality at the end. Okay? All right, let's try some more. This next one, I'm going to be subtracting 2 from both sides first. Okay, if you think about PEMDAS in reverse, the addition and subtraction would come before multiplication and division. Okay, -18 minus 2 is -20. And now I want to divide by 4. And I'm dividing by a positive number, so I don't need to flip the inequality symbol here. -20 divided by 4 is -5. Okay, so here's my solution. This is going to be a closed dot above -5. And then its number is greater or equal to -5, they'd be over there. Okay? All right. again, I've got, this time I'm going to have to do some addition and also some division. I'm going to do the addition first using PEMDAS in reverse. And then divide by -4. Okay, those will cancel. Hey, I divided by a negative, so I almost forgot to do it right there. Easy to forget. When you multiply or divide both sides by a negative number, the inequality symbol flips. Okay, 12 divided by -4 is -3. And then, so I've got an open dot, arrow going to the right. Okay, on the next page, we're going to look at some problems where we've got variables on both sides of the inequality. So you can see I have v's on both sides here. I want to have the same. I see I have a typo on the second problem. I'll fix this on the PDF. So let's make that an x. Okay, all these problems we're going to have variables on both sides. Okay, so that should be an x there. All right, so it's kind of like solving an equation where you have variables on both sides. You need to combine those variables. So I need to combine these two terms. So I need to get them both to the same side of the inequality. And I'm going to do that by adding or subtracting one of these two terms. So it doesn't really matter. I can add v to both sides if I want to move everything to the right, or I could add 3v to both sides if I want to move all the v's to the left side of the equation. I think I'm going to add 3v to both sides. Just that way my v's are going to be positive and I won't have to, divide by a negative to isolate the v. But you could do it either way, okay? So those will cancel there, and now I've got -v plus 3v would be 2v. Okay, and now it's just like the problems from the last page. So I need to isolate the v. I'm going to first add 3 to both sides. So 2v is going to be less than 8. And then divide by 2. And v is less than 4. Okay, so here's my solution. So I've got an open dot here. And I've got numbers less than 4, which would be that direction. Okay? All right, here I need to combine these x terms. So you can either add x to both sides or add 2x to both sides. I usually like the x's to be positive, or the variables to be positive if I can manage that. So that's why I'm deciding to add 2x to both sides. So let's see, now I have -7 plus x. -1x plus 2x would be positive 1x. And that's greater or equal to -3. Okay? Still want to isolate the x and also combine these two terms. So I'm going to add 7 to both sides to get rid of the 7 over here. And then x is greater or equal to 4. So I've got a closed dot there and an arrow going to the right because it's numbers that are greater or equal to 4. Okay? All right. I am going to combine my a terms, but before I do that, I want to get rid of the parentheses on this next example. So I'm going to distribute the 2 first. I'm going to use the distributive property so that I can write this without parentheses. So that would be 2 times 4 is 8. 2 times 2a would be 4a. Okay, so I got down to this. Now I want to combine these. I can either add a or subtract 4a. I'm going to add a so that the a's stay positive. So now I've got -12 is less than or equal to 8 plus 5a. Okay, on the right side, I want to get rid of the 8 and the 5, so I'm going to start by subtracting 8. So I'm using inverse order of operations. So -20 is less than 5a. Okay, and then I'm going to divide by 5. So now I have -4 is less than or equal to a. Okay, you could definitely put that as an answer. That's not an incorrect answer, but I always like to put the variable on the left-hand side of the inequality. So the alligator's eating the a. When I flip this, alligator should still be eating the a. And that's how I like to write the solution. So then I've got closed dot right here, and numbers more than -4. Okay. All right. Again, I'm going to distribute here to get rid of the parentheses. Okay, 4 times -3 is -12. 4 times 3n would be 12n. Okay, so no more parentheses. And now I'm going to start combining like terms. So I can combine those. -2 and -12 would be -14. Okay, and now I want to combine these n terms. They're on different sides of the inequality, so I'm going to have to do some subtraction to get those together. So I can either subtract 12n or I could subtract 2n. And just so the n term stays positive, I decided to subtract 2n. Okay, and then I'm trying to isolate the n, so I'm going to start by adding 14. These cancel, and now I have 10n is greater than 10. Okay, and I'm running out of space here, but my last step is going to be divide by 10. I'll have to write my solution down here. Those 10s would cancel, so I have now n is greater than 1. Okay, so I've got an open dot here above the 1 and an arrow going to the right. You could write your, you can put the open dot right on the number line. I don't like to do that because then it's sometimes hard to tell if the dot is open or closed. So I always tell my students to have their dots and the arrows floating above the number line so it's easier to read. But you could do it either way. Okay. On the last page, we're going to look at some special situations. So sometimes we get some special solutions. That's going to happen when we're solving these, when we're trying to isolate x. And sometimes the x will drop out of the inequality altogether. So if you look at this example, if I subtract 5x from both sides here, there'll be no more x's left at all. Okay? And that's kind of strange, but you'll be left with either a true statement or a false one. Okay? So if you're left with something like 3 is greater than 2, well, that's true, so that would be a true statement. When that happens, there are going to be infinite solutions. And that means anything you would plug in for x into the original equation would work. Okay, or n, or whatever the variable is. Okay, if you end up with a false statement like 7 is less than 6, well, that's not true, right? That's a false statement. That means there's no solutions, and that means there's nothing that you can plug into the original inequality that will make it true. Okay, so let's try some of these out. So when I'm getting these x terms together, let's say I wanted to pull the x's all to the left-hand side of the equation. Well, I could do this, but then both of those are going to drop out. Now I'm left with -12 is less than or equal to -4. So now I know it's one of those special situations, and now I got to decide if it's going to be infinite solutions or no solution. And the way I figure that out is by thinking about if this is true or false. This says -12 is less than or equal to -4. And -12 is less than -4, so this is a true statement. And that means I've got infinite solutions. Okay, another way you could test this out, if you forget, if it's no solution or infinite solution, just pick a number. So let's say I picked 1 for x and plug it into the original and see if it works. Well, I'd have 5 minus 12 would be -7, and then I'd have 5 minus 4 would be 1, and -7 is less than or equal to -1. It works, right? If it were a no solution, no matter what you picked, it wouldn't work. So you could just pick any, like in this next one, I usually like to pick 1, but 0 would work, and that's another. You could plug in a 0. It makes it easy to do the math. Okay, so let's try this one out. So I want to get rid of these parentheses first, and so I'll distribute. Okay, I'm left with this. Let's combine the n terms. So I'm going to add 12n to both sides, and that means there's no variables left at all. So now I'm left with -4 is greater than 2. And I decide if that's true or false. Well, -4 is not greater than 2. That's a false statement, which means I know it's going to be no solution. And yeah, again, you could pick any number you want and try it out. It's going to give you, it's not going to work. It'll give you a false statement if you plug it in. Okay. All right, let's try a couple more. So over here, I'm going to distribute to get rid of the parentheses. I've got 2k minus 10 is less than 2k plus 5 now. And I want to get the k terms together. So I'll subtract 2k from both sides, and then there's no variables left. Now I'm left with negative 10 is less than 5. Well, negative 10 is less than 5. That's a true statement, right? So then this one will be infinite solutions. Okay, let's distribute here again. So 6n minus 3. 3 times 2n is 6n. 3 times negative 1. Okay, and then when I subtract 6n from both sides, there's no more n's left at all. Now I've got negative 3 is greater or equal to 5. Well, no, it isn't, right? Negative 3 is not greater or equal to 5. So this is false, and that means I have no solution. Okay, that's the end of the section, and I'll see you next time.